Section 2.1 is reasoning and logic, and we had talked a little bit last time about some ideas that are really important for this section. The first one was actually about what a statement is and the negation, and we decided negations are pretty straightforward until we get quantifiers involved. And quantifiers had two types of quantifiers, either universal, words like all and every and none, and then we have existential, and those are words like some and at least one and there exists. And then we talked about writing negations when those things occur, and the kicker is that every time you have a negation to write, it changes quantifiers to the other type of quantifier. So all has to turn into some, or there exists one has to turn into none, something like that. And then the rest of it has to follow with the language for it to actually be the opposite of the original statement. All right, the last thing that we had sort of taken a look at is we started talking about truth tables. We had done two truth tables when we left off. The first truth table we had done was for a negation. It just changes whatever the truth value was from the original value. And then we had done a truth table for a conjunction. And for a conjunction, we talked about this and statement. Two statements are true if and only if both statements are true to begin with. And I used the example, I'm a mom and I teach math. Okay? So we're going to move along the line of from conjunction to disjunction. So disjunction is the equivalent of an or statement. And it is true if either statement is or both statements are true. Okay, so one or the other or both statements are true. And it is written like this. And it looks like PVQ. There's a V in between, and that actually means or. And so now what we're going to do is we're going to create that same truth table that we had going on last time. So we're going to have P, Q, and then we're going to have the next column here in just a second. Do you remember how we do those first two columns? They're always the same. Do you remember? All right, two trues, and then two falses. Good. And then what? Right, then they alternate. True, false, true, false. Okay, so that's going to be the same no matter what we do next. That piece is going to be there. And then what we're going to do is we're going to do this or statement between them. All right, so to have this and to think about this in this argument, I'm going to use the exact same scenario that I did last time. So we're going to think through this with the phrase P meaning I am a mom and Q meaning I teach math. And we're going to try and remember, if you guys can help me, who my people were when I gave your suggestions a moment ago. So I know I'm the first one, okay? I'm the example of the first line. So if I come into you and say, I'm a mom and I teach math, the statement would be true. Now, this one's going to be the same thing with the word or. So if I come into you and I say, I'm a mom or I teach math, the statement is also true. It sounds awkward and it sounds really strange to put the word or in there, but it is true. I am one or the other. In fact, I'm both. So it is a true statement when we start out, or when we have two true statements and an or combining them. All right, does anybody remember who my second person was? Dr. Gregory. Thank you. You guys have good memory. I'd forgotten. Dr. Gregory. So if Dr. Gregory comes in and says, I'm a mom or I teach math, is that going to be a true statement? Yes, it is. Because one or the other statement, in this case, the statement about her being a mom, is true. So this one would be true. Do we use Dr. Bandy? Is that what we use for the middle one? For the last one? Who do we use for Dr. Tucker? That's right. Okay. Dr. Tucker is my middle line. So Dr. Tucker comes in and says, I'm a mom or I teach math. And that statement actually is also true. She teaches math, but she isn't a mom. But it's still true because one or the other of the two statements is true. All right, so the last one, Dr. Bandy comes in, and Dr. Bandy says, I'm a mom or I teach math, and that would actually be false because he's neither one. Okay? So a or statement is going to be true if either of the individual statements are true. So if you have on these rows, anything in the row already that's a T, then the result's going to be T. The only way you're going to get a false result is if they both were false to begin with. That's a disjunction. Okay. Are we good? Okay, we're going to try a truth table. Just practice using a truth table. And we're going to do a truth table for the statement P. What was that one? Is it and or? And. Good. P and tilde Q. So I always have some students wondering, like, I've got a tilde Q, but I don't have a Q. That's true. You don't. But your columns need to have P and Q in them. Okay? If P is present, if Q is present, then you need a column representing the original P, the original Q, and then we'll go from there. All right, so the original P, the original Q, and I know what those columns are going to look like because they always look the same. So can you always start this problem? Yeah, always. So this is going to be true, true, false, false, and then true, false, true, false. Now, I can't just jump to the end result like I did on the last two because I need another column that represents something that's currently missing from my truth table. What might that be? The tilde one, right? It's not there right now. I need a column for the negation tilde Q. So, looking at tilde Q, we're going to go back to the column of Q, and what are we going to do? We're going to switch them. You bet. So we're going to take this column that we already had and switch them. So this will be false, true, false, true. And now if you look at the and statement that you're given over here, the individual pieces are both in a column. You have a column for P. You have a column for tilde Q. And now we can join them with the conjunction and. So we need to make sure we're looking at the right columns. This is column P, and this one's column tilde Q. Now, when is an and statement true? And they're both true, and that's the only time, right? So we're going to go along the rows, and we're going to see if we have statements that are true or false. So on the top row, we have true, false. What is that? That's false. On the second row, we have true, true. That's true. And I actually can tell you that I know the last two statements are false. Why? Because they start out with a false right here. The P column has false to begin with right here already on rows 3 and 4. So guaranteed, because it's an and statement, I have a false statement over here as well. So this is what a truth table would look like for P and not Q. All right, moving on a little bit, there is often more than one way to get a final result that says false, true, false, false. Okay? And a similar result would actually happen if you had statements that were logically equivalent. So logically equivalent means that you have two statements that have the same truth value. They either say T or F in the same places in every possible situation. Okay, so that means on every row is what that means, every row of your truth table. So that is actually written with 3 lines in between. P, triple line, Q. So if two statements are logically equivalent, we can put a triple equal sign between them. And we have 2 such statements that are written in here, although that is a problem because I don't actually have them written quite right. Give me a second and I'll fix them. These should have triple equal signs, so pardon the fact that they do not. These are DeMorgan's laws. We'll talk through what DeMorgan's laws are, but let's just look symbolically at what happens with DeMorgan's laws. So DeMorgan's law, the very first one, has a tilde on the outside of something inside of parentheses. It might feel a little bit like when you have a negative on the outside of something with algebra, okay? So what you see happen is you see the tilde now applied to each of the individual statements. So we have tilde P and we have tilde Q. What else do you see happen? Right. This was an and statement originally, and it becomes an or statement. And the same thing happens when we start out with an or statement. We can affect each of the individual statements, P and Q, individually, make them tilde P, tilde Q. But the or statement becomes an and statement. Okay? So DeMorgan's laws, in fact, I think we're going to go just a little bit out of order because I want you to actually see what they actually mean in terms of a sentence. Let's go with that. A compound statement. Let's go down to example 4. So I think I skipped it. Example 5, I'm sorry. Yeah, you guys, I've written example 4 on your paper, but it should say 5, right? Example 5. Okay, example 5 says, use DeMorgan's laws to write the negation of the following. So, when we're actually doing this with real language, what I want us to first recognize is, let's find out, is this a conjunction or a disjunction? What's joining our statements together? And is. So this word and is going to change because that's what happens when DeMorgan's laws change. DeMorgan's laws are in effect. They change the and statement into or. And then on either side of it, we have 2 statements. Right? It is not sunny, conjunction and then I will go for a walk. Okay? So this statement right now says, it is not sunny and I will go for a walk. Okay? So this is you going out on the walk when it's cloudy outside. That's what you're doing. Agreed? Okay. We're going to change this statement now. So we're going to take the it is not sunny and we're going to write the negation of that. Because that's what DeMorgan's laws do. They negate things. What is the negation of it is not sunny? It is sunny. It is sunny. What do I do with my and? I change it to an or. And then I need the negation of I will go for a walk. I will not go for a walk. Now, this is supposed to be the negation of the original statement, right? In other words, if I said, I'm about to tell you something that's not true, the thing I'm about to tell you is, it is not sunny and I will go for a walk, right? It's the opposite of that statement. The opposite of that statement is the part that I wrote in blue. So the original statement was that it was sunny, it was cloudy outside, let's say, for example. It was cloudy outside and you're walking, okay? Well, the opposite of that is, it is sunny, or you're not walking. One of those 2 things, or between them, right, has to be true to make the first statement false. It has to either be sunny outside or you have to be staying in your dorm room or going to the library or something like that, right? So this is the negation, and this is how DeMorgan's laws work in a contextual sense with negation. Let's jump back then to example 4 where we're going to do that, examples 3 and 4, where we're going to do that with actual symbols. All right, so the first one right here that they give us is they want us to do the negation of P and tilde Q. So, what are we going to do? How's it going to start? Good, tilde P, that's where it's going to start. And then what? Or. So the and turns into an or. And then Q. Good, I didn't trip you guys up at all. The opposite, or the negation of tilde Q, is Q. All it actually asks you to do is this piece right here. So you wouldn't even have to have written the first piece that I did. So is it appropriate to have 3 lines? Yes. Yes, it is. If you just put 2 lines, is it a big deal? No, not really. All right, so the next statement, number 4, is actually to verify that the 2 things that I have written down right now are, in fact, logically equivalent. In other words, that what I have boxed in blue and what I have boxed in black actually do, in fact, give me logically equivalent statements. So let me talk about how that actually works. We're going to do that with a truth table, okay? So our truth table is going to have the same P and Qs that we had before. So I'm going to have P, I'm going to have Q, and I'm going to work on the left-hand side of this equation, if you will, the part that's boxed in blue first. So just like with algebra, parentheses happen before anything else. So we need to look at what's inside the parentheses. So inside the parentheses I have a P. I wrote P down already. But I have tilde Q, and I don't have a column for that yet, right? So I need a column for tilde Q. All we're doing is working on the left-hand side that's in blue on the inside of my parenthesis. Okay? I'm going to get all my column headers listed before I fill anything in. Not because that's how it has to be done, but because I want you to see where I'm getting my column headers from. All right, so right now, working inside out, I started inside I've got everything inside of that set of parentheses individually, right? So now I'm going to join them with what statement? And. So I'm going to have a column on my truth table that's going to look like the inside of that parenthesis with the and statement. Like so. P and tilde Q. Okay, so now I did everything inside the parenthesis, and then on the outside there's something else, right? I have a negation. So I need to have a column for that. So now I'm going to have a negation of P and tilde Q. Okay, so far so good? Awesome. That's the left-hand side. Agreed? Entire left-hand side. We're going to create the right-hand side as well. So what part from the right-hand side do I currently not have listed yet? Tilde P. I'm missing that, so I'm going to need a tilde P. Okay. What else? Yeah, the whole thing, right? The tilde P or Q. And to be logically equivalent means that the two of these columns that represent the two sides of my equation, in other words, this column and this column, once I'm done with them, they better have the same TF configuration. Right? They better match. Those two columns had better match at the T's and the F's when I'm done. And if they do, then that means that they are logically equivalent. Okay? So we're going to fill in our truth table now. How in the world does our truth table start? What goes under P? True. True. False. False. Now what? Yeah, true, false. True, false. What is tilde Q going to be? We did this one before. Yeah, opposite. So false, true, false, true. All right, now we're supposed to compare a couple of columns. We're supposed to be comparing column P and column tilde Q with what connective? And. So when in the world is an and statement true? And they're both true. So the first row, are they both true? No. I have a true and a false, so that's false. Second row, remember I'm only looking at the peach-colored highlighted ones, okay? Second row, are they both true? Yes, so that one's true. What happens on the third and fourth row?
False.
They both start out false, so these are both false statements. Okay, so now what am I going to do to get this, what am I on, fifth column? Yeah, I'm just going to take the column before and I'm going to flip them. Everywhere there's a T, I'm going to put an F, and everywhere there's an F, I'm going to put a T. So this is going to look like true, false, true, true. Everybody good so far? All right. All right, let's do the tilde P column now. What will the tilde P column look like? All right, so it has to go back to column T, or P at the very beginning and switch them. So it's going to be false, false, true, true. And then I'm going to need to make a comparison with another two of them on my truth table. I need tilde P and I need Q. So the blue columns at this point now. But they're going to be combined with an or. All right, so when is an or statement true? At least one. That's a good way to say it. At least one of them is true. So one or the other or both are true, right? So when is an or statement false? Only if they're both false. So let's look at the blue columns and go row by row. So on the first row I have true and then false. That is true because I have at least one true. On the second row I have false and then I have false. That one's false. On the third row I have true and true. So that's true for an or statement, right? In my last row, I have false and true. And that's true. So the point then, in noticing this, or once we get to this point, the point is that we want to take a look sorry, I'm getting another color here. This is a good color. We want to take a look at this column and this column. Anybody else like purple? I kind of have a thing for purple. I like purple. All right, these two columns, do they match? Yes, they do. So we can actually make the argument, if we were asked to argue, why do we know these are logically equivalent? Well, because the two statements, when they're all put together, that are on the two sides of the equation that's in the first row, the first part of, or the example 3, very top of the screen, they create the same arrangement of true-false values. So by definition, that means they're logically equivalent. Any question on that one? Okay, we already did example 5. So there's one other type of connective that we're going to look at, and it's the connective that's called the conditional. Conditionals are statements expressed in the form if P then Q. Also sometimes read P implies Q. And the way that we write that is we write P with an arrow and then Q. So that arrow means implies, or that arrow means then this follows. This is what happens next. We call the part that comes before the arrow the hypothesis of the conditional, and we call the part that comes after the arrow the conclusion of the conditional. So hypothesis, conclusion. If it rains today, then my car will get wet. Right? Yeah, I mean, it will because it's sitting outside. So that's the if would be if it rains today, and then the conclusion was my car will get wet. Okay, so that's a conditional statement. All right, so the first thing we're going to do is we're going to look a little bit at how we use those symbols using some language. So we're going to let P be the statement you build it, and Q be the statement they will come. Do you guys know where that's from? Oh, good. At some point in my teaching career, I'm going to say that in class, and nobody's going to have a clue. It's just going to happen. But so far, we're doing okay. That is from a movie called Field of Dreams. And so what we're going to do is we're going to identify the pieces that are in the conditional, the way it's written as a sentence, and figure out what symbols it should use to actually be written if we would write it in a conditional form. Now, the first thing to identify is where's if. Now, if it doesn't always happen at the beginning of the sentence. In this case, it's not in the beginning of the sentence. Where is it? Kind of at the middle, right? And then the if part comes after the end. So the if actually tells us the first part. It tells us the hypothesis. So in this case, the hypothesis is actually at the end, which feels a little bit funny. But that's how we talk. And that's English for you. English is a little bit funny. All right, so we've got the part of it here says if you build it. So this part right here is where I need to start my statement. What letter represents you build it? That's actually P. And then the first part right here is the part that happens second. It's the conclusion of the conditional. They will come. What letter represents they will come? Q. So this actually is the statement P implies Q. But it almost doesn't feel that way the way it's actually said in English, right? A little bit funny. All right, part B then. This time, where's the if? It's actually at the beginning, which makes it a little bit more, I don't know, intuitive. I think that's probably the word I want. It's a little bit more intuitive with it written at the beginning. So the if's at the beginning. It says, you do not build it. What would I write to represent the statement, you do not build it? That is tilde P. Right? You build it as P, so tilde P would be you don't build it. And then what comes next is actually an arrow. And then it says, they will not come. Tilde Q. That's right. The absolute opposite of what Q was saying. They will not come. Now, it's important to realize, and we're about to get there before the lesson's over, that these two statements are not opposite of each other. I know it looks like we just put negatives on both things. We're going to talk a little bit more about that later, about what actually that means, but they are not opposites of each other. All right, we're going to do the same thing now that we did just a moment ago, and somehow I managed to do this. Well, it's okay. All right, we'll do one more statement, and then I'll have to add something in that I apparently didn't get written in here. All right, we're going to do the same thing the other way around. We actually are given the symbols, and we're going to write the statements that actually go with them. So P is the statement, God loves me, and Q is the statement, I am a sinner. Okay? So the first one says P and Q. So what is that going to be? What am I going to write? God loves me. What's next? And. Very good. And I am a sinner. So that's the first one. The second one does not have the and or between it. What does it have? It has that arrow, which is an if-then, right? It has a conditional. So I'm going to start out, the easiest way to write it is just to simply start out with the word if. So what would come after the word if? Well, remember this is actually tilde Q, not tilde P. Oh, is it different in your notes? Okay, let me change my screen so that you don't have to change your notes. Just let's do that. All right, let's say that that's what it said, since our notes already say that. Sound good? All right. My notes say that too, by the way. Evidently, I just didn't see them. All right. So you had mentioned Madison, right? Should it say? If God does not love me, then I am a sinner. Not a very good theological statement, but it is the correct language associated with those symbols.
I have a question on the last one that we did.
Uh-huh.
Okay, they will come.
Over here.
Said it's Q, but then we put P to Q.
On the first part or on the second part?
On A.
Yeah, the part on A is because the if is right here. The hypothesis has to be associated with the word if. This does not say if they will come, then I will build it, right?
So if is always Q?
If is always the hypothesis. It's always what comes first.
Okay.
So when I write it in symbols, whatever was associated with the word if, in this case it's the blue stuff, that's what comes first before my arrow. Okay? All right, there's a little bit of space. I know it says statement, converse, inverse, contrapositive. You won't need very much space. So you've got some blank space next to it. So go ahead and take a look real quick. I'll get to a blank screen. And what I needed to do, and I don't know why it's not in your notes, is I needed to do with you a truth table for the if-then, because we didn't do that. So we're going to do a P and Q, and we're going to do the P arrow Q. And I'm going to do different statements than I did before. P is going to be the statement, I am a mom. And Q is going to be the statement, I am a woman. We're going to do the same kind of thing we did last time, where we're going to pick people that you know around campus, and we're going to try and fit them into the categories. All right, so here's the first statement. We're going to come in here, and these statements are always the same at the beginning, right? True, true, false, false, true, false, true, false. All right, so I walk in, and I say, or actually, you don't even have to see the person, okay? You don't have to see me. I'm standing out in the hallway, okay? And if I use the word doctor, then you don't know if I'm a man or a woman, right? Okay, so let's say that that's what happens. So the person out in the hallway says, and it's me, Dr. Hands, I am mom. So is it obviously necessarily true then that I'm a woman? Yes, it absolutely is. So this is a true statement right here. If I'm a mom, then I'm a woman. Absolutely true. Okay? How about the second one? The second one says, if I'm a mom, then I'm not a woman, because that's what the false there means, right? Is that possible? It's not possible. This is a false statement. If somebody came to you and said, if I'm a mom, and they were a mom, and then they said, but they're not a woman, that would be a little concerning, right? That is not biologically true, okay? All right, let's do the third one. The third one would be the statement that someone says, I am not a mom. So these are the two that are always a little tricky. I am not a mom. And that's actually both the two statements at the bottom, right? So if Dr. Tucker says, I am not a mom, Dr. Tucker, female math professor, I am not a mom, can she still be a woman? Well, absolutely. In fact, most of you probably fit into that category, right? Yes. Absolutely, totally true, and possible. So the default is, it's kind of like this. I'm going to believe you until you give me a reason not to believe you, right? So if the person says, I am not a mom, but I'm a woman, all right, but I'm a woman, you're going to be like, yeah, okay, that can be a true statement. But then what happens if Dr. Bandy comes in and he says, I am not a mom, therefore I am not a woman? And you'd say, yeah, okay, that's true too, right? Because there's no way of actually being able to know for sure that it's false. It's not a guaranteed false statement. It has the ability to be true. So in a conditional, the only place where you know it's false is if the statement starts out true and it ends false. So this is my only false conclusion inside of a conditional. A true-false comparison. The first statement's true, the second statement's false. We get a false result. Okay? All right, so let's go back to where we were before, and we're going to do the conditional comments. And this is where our fun video from last time is from. All right, a statement. So if we have a statement, and it's written in the form P arrow Q, if P, then Q, then the converse of the statement is to do the same thing, but reverse the P and the Q. So it would look like Q arrow P. Now, obviously, this does not create a statement that's the same as the first statement. Okay, so if my first statement was, if I'm a mom, then I'm a woman, and my second statement says, if I'm a woman, then I'm a mom, that's a problem. So it's not true, right? It's not a true statement. So these two statements are not logically equivalent. Agreed? I mean, it doesn't work. It didn't work for my one example, in fact, so it can't work in general. All right, inverse. What inverse does is it keeps the P and the Q in the same location as the original, but it negates them. Okay, so again, if I'm using my mom woman example, it's say, if I am not a mom, then I am not a woman. Now, wait a minute. That's not the same statement, right? I don't know that for a fact. It's not a guaranteed. So that doesn't work. It's not equivalent to the original statement. The third one is contrapositive. So on contrapositive, we're going to switch the order of the letters, and we're going to switch the negations. So I'm going to have the negation of Q, arrow, the negation of P, like so. We haven't done this one yet at all in my language, but let's go with it. It says then, if I am not a woman, then I am not a mom. That's true, right? Here's the kicker. The first statement and the last one, the contrapositive, these are logically equivalent. Not only that, but the two in the middle are also logically equivalent, which is why one of them didn't work, so it doesn't the other one not. The two in the middle are logically equivalent. The first one and the last one are logically equivalent. And there's an example where you're going to explore the logically equivalent stuff with group work on this. All right, one fun example to end with. Oh, I didn't get mine fixed on here. It's the monkey example, right? I changed it from the last time I taught it because I thought it was fun. All right, so it says, if I am a monkey, I have a tail. And this was actually what Larry the cucumber was told by the lady at the zoo. Okay, this is what he was told, and then he got it all mixed around and confused and weirded up, okay? But this is the original statement. So we're going to write the converse, inverse, and contrapositive. So what does a converse do? Switches what? It switches P and Q. So it switches the order of the way that it's written. So what's going to be coming at the beginning of this? Well, the first word is if, but then what's going to come after the if? If I have a tail, what will come next? Yeah, and if you want to use the word then, you can. Then I am a monkey. Is that true? No. We saw a picture of a cow, right? Do you remember that? That didn't work. Okay, the second one was inverse. So what do we do for inverse? We negate both of them, but we keep the order, right? So it will say if I am what? Not a monkey. Then what? I do not, or I don't, whatever you'd like, have a tail. And again, this doesn't work because we could still be a cow, right? We or it, if you prefer. We're not cows, but you know what I mean. All right, the last one, the contrapositive. Contrapositive. Okay, so what are we going to do on the contrapositive? If I do not have a tail, okay, so we negated the second half. We're changing the order. Then I am not a monkey. And their example of this, when they were looking at this, was an ape, right? That's what they were talking about in the scenario. This is the same as the original statement. If I'm a monkey, then I have a tail. If I do not have, a tail, I got carried away, then I am not a monkey. Those are logically equivalent statements. However, it does beg the question, what is Curious George? So I'll leave you with that to think about.